The next component of steam systems is the steam boilers. So there are so many types of boilers available in the market, uh, but we can easily distinguish them based on the steam output pressure, the steam pressure, the steam output, basically the capacity, and the fuel types. The fuel types can be gas, like an LPG, can be a liquid fuel, can also be the solid fuel, like a coal or even the wood. Um, Most important thing is probably the steam pressure. So there are four classification of the pressure coming from the boiler. So the first one is high pressure, which is the 100 bar gauge. This is normally used for power generation. Okay. The second one is at a pressure about 40 bar gauge. Okay, 40 bar gauge is basically means 41 absolute bar. Um, it is the uh, it is the normal maximum pressure for distribution. So this is basically the maximum pressure for distribution. Then at the pressure range of 10 to 40 bar gauge, so it is the uh, operational pressure, the more or less pressure used in the system. So pressure used in the system, pressure in steam system. And lastly, low pressure, which is around 2 to 5 bar gauge, is basically the typical lowest pressure used in the system. Okay, this figure it illustrates a type of boiler called as fire tube or shell boiler. It consists of a large cylinder. So basically, this is a large cylinder. Um, the cylinder houses a pool of boiling water. So if I make an illustration here, so these are the boiling water. These are the boiling water. So anything in the shell side, those are the boiling water. Okay, up to this one. Okay, and the hot flue gas. The hot flue gas is actually flowing. So I'll put, flowing through the tubes. So it's flowing through these tubes and go. That's tubes. Okay, to the flue gas. So that's the configuration. So the steam pressure is contained by this large cylinder, which impose a certain mechanical limitation. So large diameter of cell then requires a thicker wall to contain the same pressure as the smaller shell. So because of the cell is quite large cylinder here, the economic limit for this kind of boiler is at a pressure of 20 bar gauge. But of course, they are available at higher pressure. So because of this design, the fire tube boilers are normally used for small heating duties of low pressure system. The fuels are normally restricted to gas or light fuel oil. Another type of the boiler is the water tubes boiler. So water tubes boiler vaporize the steam through the recirculation of water and steam between the steam drum, steam drum is, wait, the steam drum is here. So this is steam drum. So you see that the water is circulated between. So you see here that you have it goes there, so it goes up the steam, and then also the water goes down, steam goes up. So the steam from the steam drum is then superheated before entering. So this part is basically, this is superheating part. So in the earlier part, around here, it's mostly the saturated steam, because you have a liquid and steam at the same container here. So to be able to, so when you have both liquid and steam, basically you can only reach the saturated steam condition. So to be able to form the superheated steam, so the steam is further heated in this coil to form superheated steam. So this type of boiler is suitable for high pressure and high steam output. The fuel can be gas, oil, or the solid fuel. And in the case of the solid fuel, the boiler must have some mechanism for removal of the ash, because when you burn the solid fuel, you need to remove a lot of ash. Okay. Apart from the two type of the boiler discussed here, there are many other type of boilers available to generate steams. Okay. Another aspect, important aspect of the boiler is the boiler blowdown. You can refer to the previous video about the boiler blowdown. So the boiler blowdown is required to maintain the solid concentration inside the water in the boiler. The reason why we have solid is that although we done a lot of pre-treatment of the feed boiler, there will be always some of the residual solid that escape from the treatment. Since in the boiler only pure water evaporate and solid remains in the liquid form, as function of time those solid will accumulate and then my corrode the boiler or my foul the boiler stick on the wall and reduce the performance efficiency. So to prevent the build up of the solid in the boiler, uh, we have the blowdown or purge stream. So it's to avoid the carryover of solid to the steam system. And there is a term of blowdown rates. It is defined as the ratio of flow rate of the blowdown to the evaporation rate. So ideally, blowdown rate is really affected by the concentration of the solid that enter from the boiler feed and the limit of the boiler itself, because some of the boiler can comply with a high concentration of solid, other cannot. So it's really affecting how much the blowdown. Ideally, we want to have as small as possible blowdown from the boiler. So another important thing about the steam boiler is the steam boiler efficiency. If you look into the video in chapter 1, you might see a bit similarity. In the chapter 1, we discussed about a furnace. Actually, a furnace can also be a boiler, right? For example, here, you see this line. Okay, this line is the operating temperature of the boiler. Okay. Operating temperature of the boiler, you can imagine that this one is the actual flame temperature here, very high, and then as it goes, this is happened probably in the fire in the combustion chamber. So as the as the heat is uptaken by the tube boiler, you see here that there is a transfer of heat. So the temperature goes down, uh, until it reach a temperature of the stack. Basically, that's it. So basically, these are the range of the temperature of the process that we use to generate steams. Beyond this one, it's basically kilos. Okay, the heat that is lost through the stack. Okay, so that is from the heating fluids, basically the flue gases stream. You can also look into this graph from the other part. So T0 here is the ambient temperature, normally 25 degrees Celsius, or we can also assign this temperature as the standard temperature. Then first of all, the water is normally at this temperature. Before it's enter the boiler, remember that during the pre-treatment of boiler, we steam the water to remove the dissolved oxygen and carbon dioxide. So basically, this is a boiler feed water temperature. Okay, it's around here, and then heated to the temperature of the this is a boiling temperature, a saturation temperature, a boiling temperature, and then during this along this line is basically partial evaporation of the liquid, and then from here is the steam is further superheated to form the superheated steam. So based on these two temperature gradient, then the term of boiler efficiency is defined. So the boiler efficiency is defined as the Q steam is basically all of the heat from the boiler that is converted into the heat of the steam divided by the total heat supplied by the fuel. So that's the basic definition. So then heat from the fuel based on this classification then is equal to the heat of the steam plus the heat loss. The major inefficiency of boiler is coming from the heat loss through the stack, as you can see from here. So the minor heat loss here can come through the conduction of the boiler wall. Also, some of the heat is carried over by the blowdown of the boiler blowdown.